Hello everyone, welcome back to my YouTube channel Unfog with Dr. ATAHAR PARVEEN. In this session, let's continue discussing optics, and this is the part 2 lecture of optics based on HSTR, KREIS, TET, Karnataka TET and KV syllabus. If you have found my channel just now, then please do subscribe to my channel and hit the bell icon so that you get the notifications whenever I upload the next video. And if you have already subscribed my channel, then please like and share the lecture with your friends, relatives and other aspirants. We know that from this chapter we will have at least 5 questions in the exam and we don't want to miss them, right? Here the red lines, they show the GPSTR syllabus. If you are a GPSTR aspirant and if you have attended my GPSTR classes, then you will know that we have covered all this portion in GPSTR time. But then the GPSTR pattern was different. You had the descriptive answers also. But in HSTR, we don't have any descriptive part. We have just multiple choice questions. Now, I was telling you that the red lines, they show the GPSTR syllabus. Now, they have added more syllabus to make it a HSTR syllabus. So, the blue lines, they indicate the HSTR syllabus. So basically this entire portion of optics is for HSTR, KREIS and TET syllabus. In this lecture we shall cover just this part, that is basically the refraction part. In previous video we discussed the mirror and the reflection part. We also discussed laws of reflection there. Also we discussed the uses of mirror and different types of mirrors and how the images were formed. In the same manner, in this video, we are going to discuss about lenses, the formation of images in lenses or in different types of lenses and a different object position, then the power of lens, then the uses of these lenses and the refraction part. Also, we will discuss the laws of refraction in this lecture. Before that, I want to mention one important point regarding the previous lecture. These are the 2 questions which I asked as assignment in the previous lecture and I asked you all to comment the answers in the comment section. Here I want to clarify one point. Regarding this question number 29, though it is okay, the phenomenon by which the incident light falling on a surface is sent back into the same medium is known as reflection. Okay, this is the answer. But for question number 30, 2 mirrors are inclined at an angle of 50 degrees, then what is the number of images formed for an object placed in between the mirrors? In our previous video, we told that the number of images formed when 2 plane mirrors are placed at an angle A with respect to each other is given by 360 upon A minus 1. Or if the angle is theta, then the number of images formed will be 360 upon theta minus 1. So this formula n is equals to 360 upon theta minus 1 is used if the integer in the angle is a even number. The angle means the angle made by the 2 plane mirrors. For example, if the angle made by the 2 plane mirrors is 60 degree. In 60 degree the integer is 6, right? That 6 is a even number. In that situation you use n is equals to 360 upon a minus 1 or n is equals to 360 upon theta minus 1. If you have the integer in that angle as 5, for example as given in this question as 50 degree, here the integer is 5. That means it is odd number, right? If the integer is odd number, then number of images formed will be equal to 360 upon theta. You will not have minus 1 here. 360 upon theta or 360 upon a. Okay, I hope you got my point. So here in this question, we are not going to use this formula 360 upon a minus 1. Instead, we use 360 upon a because 5 is an odd number here. For example, if you had 90 degree, then also you use this formula 360 upon theta only. Don't use 360 upon theta minus 1 because 9 is an odd number. Okay. So if I want to solve this question number 30, then I use this formula 360 upon theta or 360 upon 50. So I get number of images as 7. So option D will be the right answer here. Before starting the class, I would like to request you all, if you are watching this video for the first time, please go back and watch part 1 of optics, the previous video, then come back and watch this video, because many of the concepts which I have cleared in part 1, I am not going to discuss on them in this chapter, and many concepts are connected also. So please watch part 1 of optics, then only watch part 2, the present video. Okay, I will also give the link of the part 1 video in the description. Now let us proceed with the refraction. Now what is refraction? See, when a light travels from one medium to another medium. For example, if there are two mediums, light is traveling through air and then it is falling on the surface of the glass. Then the speed of the light changes, because here there are two mediums with different densities. Air is rarer medium here, and because glass is denser than air, so glass is said to be the denser medium here. So whenever light passes from one medium to another medium, that is, for example, from rarer to denser medium or from denser to rarer medium, the speed of the light changes, and also the light bends or the direction of the light changes when it enters into the another medium. Here, for example, air is rarer medium, right? And glass is denser medium. See, just you imagine, when light is moving through air, then it is moving freely because it is gas, right? As it enters into the glass, the other medium, which is a solid, here molecules are tightly packed, then the light will have sort of little bit of obstructions to pass, isn't it? So the speed of the light will decrease here, and also the light bends towards the normal while entering into the denser medium. For example, look at this picture. Here you can see that if I draw a normal, then as light touches the surface of the glass, it is bending towards the normal. Okay. Now, like reflection, refraction also follows certain laws. The first law is that the incident ray, the refracted ray, and the normal to the interface of two transparent media, they all lie in the same plane. And the second law is well known as Snell's law of refraction. It states that the ratio of sine of angle of incidence to the sine of angle of refraction is equal to a constant, and that constant is known as refractive index, or n. We sometimes also write as mu, the Greek letter. Okay. Usually we tell it as n. Now if I say that if the two mediums, the air and glass, for example, have two different refractive indices, then for air maybe it could be n1 and for glass it could be n2. Then instead of writing sin I by sin r is equal to n, I can also write as n1 sin I is equal to n2 sin r. And also this refractive index of the medium, it depends on speed of light in the medium and speed of light in air. We know that the speed of light in air is 3 into 10 raised to 8 meters per second, right? So this refractive index will be equal to speed of light in air, C, upon speed of light in the medium. About speed of light in the medium, it will be mentioned in the numerical. You should be knowing the speed of the light in air, which is 3 into 10 raised to 8 meters per second. Then speed of light in the medium will be given. You can easily find the refractive index. Now, it is better to remember three values of refractive indices. First is of ice, then water and diamond. At 0 degrees Celsius, the ice is having the refractive index of 1.3 and water has 1.33, diamond has 2.419. With this table, you can infer that ice has the lowest refractive index and diamond has the highest refractive index. All this can be asked. See, whatever I am teaching, whatever I am discussing in this video or my any other previous videos, every line is important. Especially in this video, every line is important because anything could be framed as a question and asked as a MCQ. Now we are saying that if light is passing from a rarer medium to a denser medium we took it as a glass now. That glass, it could be a slab, it could be a prism also, right? Then even in prism, if the light falls on the surface of it, then refraction should take place and the change in direction should happen and the speed of light should change, isn't it? Now, whether this prism surface is a straight line or it is curved, this should happen, right? Now, if I use both these things, the prism and the slab, and then arrange it in a proper way, then I can create what is called as lens, a convex lens and a concave lens. The first one is a convex lens which can be made by small prisms put one upon one together along with the slabs in the center. And then the second one is the concave lens which can be made by putting the prisms in opposite direction and slabs can be put in a vertical direction in the middle. Now these lenses, they form images by refracting light. Same like the mirrors which formed images by reflecting light, these lenses form images by refracting light. Now let us talk more about these lenses. See, first we are talking about convex lens. Here you can see that the convex lens, it is made by sticking two spherical surfaces together. It is thicker in the middle and it is thinner in the edges. This convex lens is also called as converging lens. The images formed in the case of this lens, the convex lens, are same as that which were formed in concave mirror, which we discussed in the previous class. And because of the converging property of the convex lenses, they are used in microscopes, in magnifying glasses and in camera lenses. And in the same manner as the convex mirrors which we were talking about in the previous video, in the same manner the concave lens diverges the light after refraction. Okay, this is made by two spherical surfaces bounded together, and here in the center it is thin and at the edges it is thicker. Here the image formed, as I told earlier, it is same like that which is formed in the convex mirror, and this is used in spectacles, binocular, telescopes and in photography. To put it in a simple manner, concave and convex lenses, they form opposite images to that in concave and convex mirrors. This one line, if you put it in your mind in a permanent way, then I promise you most of the answers in your exam will go right. Okay. Concave and convex lenses form images opposite to that in concave and convex mirrors. Convex lens is thicker in the center and it is thin at the edges. And example, the best example for convex lens is magnifying glass. And concave lens, it is thicker at the sides and it is thin in the center. And the best example for the concave lens is that people who cannot see far objects, they use concave lens in their spectacles. Okay. We will follow the same strategy as we followed for the mirrors. Now same thing we will go on talk about the same way we did for mirrors. We were talking about image formation in mirrors using ray diagrams at first, right, in our previous video. So we'll do the same thing here. Here you have to note that in place of this pole, there is an optical center because the lenses are made together with, they are bounded together with two curved surfaces, right? So we call the center of the lens as the optical center. Where we were using the word pole there, now we use the word optical center. Okay. The first scenario here is that if a ray of light from the object, it is coming parallel to principal axis, then after refraction in a convex lens, it passes through principal focus on the other side of the lens. And in a concave lens, the ray appears to diverge from the principal focus located on the same side. Here we draw the imaginary line which meets at the principal focus. Now second case is that if the light is passing through principal focus in the convex lens, or if it is appearing to meet at principal focus in a concave lens, then after refraction, in both the cases, the light emerges parallel to the principal axis. Then the third case, like the same way which we did for mirror here, the light, if it is passing through the optical center, in both the cases, then after refraction, it will emerge without any deviation. Okay. So it's better if you have made notes for the previous video, please take that notes and sit for this video while watching it. Then you can easily compare with what I am telling, you can relate and it will be very easy for you to learn. As you are watching my video, then only you can learn, so that you don't come back again to read and you waste your time. Okay. Now let's talk about image formation in convex lenses using ray diagrams. The first trick which I am going to give you here is, whatever the table you are seeing here, it will be same for the concave mirror. So please note that there are two focal lengths for a lens. One is on the left hand side of the lens and the other one is on the right hand side of the lens. You can see the table. It is the same as that we were discussing for concave mirror. First one is that if the object is placed at infinity, then the image is formed at focus f2. And if the object is placed beyond 2f1, 2f1 means it is nothing but center of curvature. Okay. If the object is placed beyond center of curvature, then this image position will be also beyond the other center of curvature. Now the other center of curvature is 2f2. Okay. And third case, there we were telling that at the center of curvature, if the object is placed, then you will find the image at the center of curvature only. But there we had only one center of curvature. Here we have two center of curvatures on the either side. So the image will be formed on the either side. Okay. Then the fourth and fifth, same funda you can apply here. Put it as a center and then you see, you just reverse them. If the object is beyond 2f1, then the image is formed between f2 and 2f2. What will happen if the object is between f2 and 2f2? The image should formed beyond 2f2. Same funda you apply here also. If the object is at infinity, image is formed at focus f2. What will happen if the object is at focus f1? Image is formed at infinity. Okay. Except the last case. The last case, if the object is put between the focus and the optical center, then the image is formed on the same side of the lens as that of the object. Okay. This is one different thing. And even the nature of the image. For all the rest of things, it is real and inverted, except for the last one, which is virtual and direct. Okay. And regarding the sizes, you can just look into it. Everything will be same as the concave mirror. Now coming to the image formation in concave lenses. See here, the simple trick is that it is same as that of the convex mirror. Whatever we were talking in our previous video, everything will become opposite here. Whatever we told for concave mirror will become for convex lens. Whatever we told for convex mirror will become for concave lens. Okay. Same thing. You can just match the table and see if you want. Only the thing is that here names are little slightly different. There we had pole, here we have optical center. There we had center of curvature. Here we address center of curvature as 2f. If it is on the left hand side, it will be 2f1. If it is on the right hand side, it will be 2f2. But for concave lens, everything is on the left hand side only. Okay. And we were talking about the sign convention, right? The sign convention is same as that of the spherical mirrors only for lenses also. Okay. Only thing you have to remember is that focal length of convex lens is positive and for that of concave lens it is negative. It was same for mirror also. And then you have to apply the signs for the values of u, v, f and height of the object and the image properly. That you have to imagine with the coordinate system and then you have to apply the signs. But still, if you remember the second point about the focal length, then very less chances are there of making mistake. Okay, just remember the second point. Like we had the mirror formula, we have a lens formula here. The relation is between the object distance u, image distance v and focal length f. But there remember we had mirror formula with a plus sign. There it was 1 by u plus 1 by v is equal to 1 by f. But for a lens it is 1 by v minus 1 by u. Remember, this is very, very important. Okay, in lens formula you will have a negative sign. And then magnification, there magnification we had minus v by u, right? Here magnification will be v by u. So remember, everything is opposite. Okay. So just write down this table in your notebook and then you can cross check it as a revision later on after watching the video. Okay. Now let us see the difference between concave lens and convex lens. The concave lens, it will be thick at the edges and it will be thin in the center. Convex, it will be ulta. And then in concave lens, you will have only virtual images. But in convex lens, you will have real as well as virtual image. They both can be formed here. And then in concave lens, you have erect and small sized images. And in convex lens, you will have erect also, you will have inverted also, you will have small also, you will have magnified also. All sort of varieties will be there in convex lens, like in the concave mirror. And then concave lens is called as diverging lens and convex lens is called as converging lens. And most importantly, you use concave lens for short sightedness or myopia, and you use convex lens for long sightedness or hypermetropia. What are the differences between mirror and lens? That positive sign you put in between 1 by u and 1 by v for mirror formula, and negative sign between 1 by v and 1 by u for lens formula. And in magnification also you have negative sign for mirror, and in lens you don't have negative sign for magnification. Okay. So this is a simple summary. I hope you all understood till what we have talked till now. Now coming to power of a lens. Now what is the power of a lens means? It is the degree of convergence or divergence of light rays achieved by a lens. Usually we define it as a reciprocal of the focal length of that lens. Okay. So power P is equal to 1 upon F. There are certain points which you have to remember. They can be asked as MCQs. Okay. So SI unit of power is diopter. It is denoted by capital D. Then if the focal length is expressed in meters, power will be expressed in diopters. So 1 diopter is the power of a lens whose focal length is 1 meter. Because 1 diopter is equal to 1 by F. So 1D will become 1 per meter. It will be reciprocal. Then power of convex lens is positive and that of concave lens is negative. Remember, same thing was there for focal length in a mirror. Okay. Same thing is here also. Just to put power in place of focal length. And then opticians, they prescribe corrective lenses indicating their powers only. Those lenses can be identified with the power. For example, if the lens is prescribed with power equal to plus 2 diopter, it means that the lens prescribed is convex lens because it is positive, right? The power is positive for convex lens. And the focal length will be 1 upon 2. So it will be 0.5 meter. Similarly, if the lens is prescribed with power minus 2.5 diopter, it means that the lens has focal length of 1 by 2.5, that is 0.4 meter. And because the power is minus, then the lens is concave. So you have to remember that the power of convex lens is positive and power of concave lens is always negative. Now opticians, they prescribe the corrective lenses indicating their powers, I told you, right? Now there are few common defects of vision which can be corrected using these lenses. For example, the most common defects are myopia, which is also known as short-sightedness or near-sightedness. Here no person can see only the nearby things. Means he can read a book nearby but he cannot see the far away things. Here, concave lens is used to correct this myopia. Then, hypermetropia. It is also known as long-sightedness or far-sightedness. Here, for this defect, convex lens is used because here focal length is always positive. That's why convex lens can be used to correct this hypermetropia. Now, the another common defect is presbyopia. Here, a person, he may have both far-sightedness and short-sightedness. In these situations, the opticians, they prescribe a corrective lens known as a bifocal lens. Okay. Now, they can ask any question among these three. In 2015, they have asked for hypermetropia. Maybe this time they may ask for presbyopia. For example, the question can be like this. Lens is used to correct the defect of vision termed as presbyopia. Now, as I told you, the lens used will be bifocal lens, and in this lens, the upper part will be made up of concave lens and the lower part will be made up of a convex lens. Okay. With this combination, the person suffering from presbyopia can have a good vision both in far and in short. Okay. So, the answer will be bifocal lens. Now, based on this lecture, I am going to solve multiple choice questions. So let's start. First, let's start with the power of a lens only. As I told you in 2015, the question was asked on hypermetropia. The question was, a person uses a spectacle of power plus 2D. Then he is suffering from the eye defect. See, plus 2D, convex lens. Convex lens is used for hypermetropia. So option 4 will be the right answer. Okay. Now let us solve more questions. All these questions are the expected questions which I have collected for you all. Believe me, this is more than enough to prepare for this part of optics. Okay. First question. The SI unit of power of a lens is, as I told you, the SI unit of power of lens will be diopter. So option B will be the right answer. Next question. The power of a lens having a focal length of 1 centimeter is, I told you that 1 diopter means focal length will be 1 meter. For centimeter, you have to divide it with 0.01. Then you get this 1 upon 0.01 will be equal to 100 diopter. So option C will be the right answer. Next question. The focal length of a convex lens is 50 centimeter. Its power in diopter is, see, given that focal length is equal to 50 centimeter, you have to convert it in meters because we have to find the power in diopter, right? To convert it in meters, you divide it with 100. Then you get power will be equal to 1 upon 0.5 or 2 diopter. So option 3 will be the right answer. Because they are talking about a convex lens, power will be plus. So you have to tick with plus 2, not minus 2. Okay. Moving on. What type of image is produced by a concave lens? See, it is always virtual and reduced in size. Because it is opposite of convex mirror, right? So, a concave lens, it will produce an image that is always virtual and reduced in size, while convex lens, it will produce virtual image only when the object is in between focus and curvature. Next question. What is the least distance for distinct vision? The least distance for distinct vision means it is the least distance or the smallest distance at which a human can see two letters separately. For example, you are reading a book. In that you have to see the letters separately, means that book at least you have to keep at certain distance. That distance is 25 centimeter. If you keep less than 25 centimeter, then you cannot see that letters separately. You will have this blurred thing. You cannot read properly. You will find all blurred letters in the book. Okay. So this least distance, it is defined as the minimum comfortable distance between the object and the eye lens to form a clear image. Here option B will be the right answer. Remember this 25 centimeter. It is the least distance for distinct vision. Next question. From which part of the lens the ray of light passes without deviation? Of course, it should be optical center. In our concave. Next question. What are concave lenses? What are concave lenses? They are thinner from center than at the edge. They are thicker at the edge, right? They are thinner at the center. So option B will be the right answer. What is the power of lens? Of course, power of lens, it will be the reciprocal of focal length. Option C will be the right answer. Next question. Name the bending of light if the beam of light passes obliquely from one medium to another. Note down here it is asked as one medium to another and bending of light. That should be refraction. Next question. From which part of the lens the ray of light passes without deviation? Of course, it should be optical center. Next question. Light from the sun falling on a convex lens will converge at a point called. The point where the light will converge is called focus. Next question. A divergent lens will produce always real image, always virtual image, both real and virtual image. None of these. So the divergent lens, it will always produce virtual image. Okay. Divergent lens means concave lens. You have to remember this. Next question. When object moves closer to a concave lens, the image by its shift away from the lens on the same side of the object, toward the lens, away from the lens on the other side of the lens, or first towards and then away from the lens. See, in this type of questions, no, you better don't read options so many times. You just recall what happens in a concave lens. Here, the image, it will shift towards the lens. Option B will be the right answer. A magnified real image is formed by a convex lens when the object is at. Means when we will get the magnified real image in a convex lens, you will get only in one situation, that is when the object is placed at 2f. You get real, inverted and same size image in a convex lens. So according to the question, both option A and B should be the correct answer. That's why here option D will be the right answer. Next question. Which of the following can make a parallel beam of light when light from a point source is incident on it? So which of the following can make a parallel beam of light? Concave mirror as well as convex lens, convex mirror as well as concave lens, two plane mirrors placed at 90 degree to each other, concave mirror as well as concave lens. Of course, it should be concave mirror as well as concave lens. They can make parallel beam of light. Okay. Next question. The deviation of light ray from its path when it travels from one transparent medium to another transparent medium is called. Of course, again it is refraction. They can ask in any type. They can twist and turn and make a question, but your answer will be the same. That's why I am giving you different type of questions with same answer. I want you all to get this point that the twisted questions can have same answers. So you should know the concepts clearly. Okay, moving on. If the power of a lens is minus 4.0 D or diopter, then it means that the lens is a. So here don't see options, just to calculate and then you take the right answer. Whatever answer you are getting, you match with the given options. Okay. So what you do here, power is given and there is a negative sign. That's why it should be a concave lens. Then you have power is equal to 1 upon focal length, or focal length will be equal to 1 upon power. Just substitute the values. This 1 upon P can be written as 1 upon 4, but then they are giving as diopter. That means you should have the focal length in meters. That's why I am multiplying it with 100 centimeters. Then you get answer as 25 centimeter. But then it is a concave lens. That's why you will have minus 25 centimeter focal length. So option C will be the right answer. Next question. Light waves travel from optically rarer medium to optically denser medium. Its velocity decreases because of change in, of course, it should be wavelength, because frequency remains the same. Remember, V is equal to F lambda. Velocity is directly proportional to the wavelength. We have done this in chapter sound in GPSTR time and in electromagnetic radiation chapter here in HSTR time. So V is proportional to wavelength, but then it is proportional to frequency also, but then frequency remains same when the light travels from optically rarer medium to optically denser medium, or optically denser medium to optically rarer medium. Frequency is not affected. That's why velocity will decrease because of change in wavelength. Option B will be the right answer. Next question. When light is refracted into medium, its wavelength and frequency both increase. Its wavelength increases but frequency remains unchanged. Its wavelength decreases but frequency remains unchanged. Its wavelength and frequency both decrease. See, don't go into options. You know what is happening in refraction, right? Its wavelength will increase but frequency will remain unchanged. Okay. Next question. If a convex lens of focal length 80 centimeter and a concave lens of focal length 50 centimeter are combined together, what will be the power of combination? See, this concept I have not explained you in class. I thought that I will give an example and I will explain you here itself. See, if you have two lenses, if you are combining together, then you can combine their powers also. You can combine their focal lengths also. For that you have this formula. Actually, if you know that power is equal to reciprocal of focal length, right? But then you can combine the focal lengths. If the two lenses you are combining together, then you can add those focal lengths, but then you have to take the reciprocal of each focal length. Okay. For example, if you take this question, here they have given you the focal length of convex lens. Let that be focal length f1, and they have given you the focal length of concave lens. Let that be focal length f2. Now you can take their reciprocals and you can add them. 1 upon 0.8. I am converting this centimeter into meter because we have to find power in diopter. So 80 centimeter will become 0.8 meter and 50 centimeter will become 0.5 meter. 1 upon 0.8 plus 1 upon 0.5. Actually, this 0.5 has a negative sign here because we are talking about concave lens. Focal length of concave lens will be equal to negative of that value. So I am taking 1 upon 0.8 plus of 1 upon minus 0.5. Basically, I will have to subtract here. 1 upon 0.8 minus 1 upon 0.5 will give me minus 0.75 diopter. Okay, you can just calculate this by taking the LCM. You calculate and let me know whether you are also getting minus 0.75 diopter or no. So here option D will be the right answer. Similar question I will give you again. Two thin lenses, one of focal length 60 cm and other of focal length minus 20 cm are placed in contact. The combined focal length is, here they are not asking you power, they are asking you directly the focal length, and they have not given you types of lenses. They have given you plus 60 cm, that means it is a convex lens, and the other one they have given you minus 20 cm, that means it is a concave lens. Okay, now you use the same formula. 1 upon f is equal to 1 upon f1 plus 1 upon f2. You substitute the values and you find 1 upon f's value. After that you take the reciprocal, you get f value. Here it will come out to be minus 30 cm. Okay, here also in the same manner you have to take LCM and then you have to take the reciprocal. You calculate it, you simplify it and let me know whether you are getting minus 30 cm or no. Okay. Next question. A convex lens is to be used to throw a magnified image of an object on screen 10 meters from the lens. If the magnification is to be 19, the focal length of the lens is. See, here magnification comes into picture. See, here they have given you the image distance, that is 10 meter. That will be your V. With this you can find magnification, right? Magnification 19 they have given. V is 10 meters, you know. Now you can find the object distance, that is U. That U will become 10 upon 19. Using this you can find the focal length, right? Because we have this lens formula, 1 upon f is equal to 1 upon U plus 1 upon V. Just substitute the values, you get 1 upon f is equals to 20 upon 10. So 1 upon f will become 2. Now you take the reciprocal, you get 0.5 meter. So option A will be the right answer. Now these two questions you have to answer by yourself. This is your assignment. You have to give the answers in the comment section. Okay. That's it for this class. I have finished the refraction part and we have solved enough of numericals based on these lenses and refraction. I hope that you all are happy with this class. Do let me know your feedback in the comment section. And once again, I would like to request you all to share this lecture with your friends and HSTR, TET, KREIS aspirants. Okay, then that's it. Please do like, share and subscribe to my channel. And if you have any doubts, you can please let me know in the comment section. You can also join the Telegram channel. I will give you the link in the description. Okay. All the best. Thank you. Bye.